Hi friends, today we would be doing a topic called clocks. So this is just an extension of our concept of relative speeds, right? We have already studied relative speeds in our time, speed and distance chapter. So let's just extend the logic of relative speeds to clocks and see what kind of questions can be asked from this chapter. The concept is pretty simple. We have two hands in clocks which we would be dealing with. One is the minute hand and the another one is the hour hand, right? We all know that a minute hand runs what? 360 degrees in 60 minutes, right? Or we can say the speed of the minute hand is 6 degrees per minute. So here what we are doing is we are finding the speed of each hand in degrees per minute. Similarly, an hour hand moves 360 degrees in 12 hours, right? For example, if now it's 12 noon, right, the hour hand would again come to 12, or it would again point to 12 at 12 midnight, which means after 12 hours. This means 360 degrees in 12 hours or 30 degrees per hour, right? So if you see that the angle which the hour hand makes when it is at 12 and then when it is at 1, it's 30 degree, right? Or 0.5 degrees per minute, right? Now they are traveling in the same direction, which we say is a clockwise direction, right? So the same direction is clockwise direction, right? So we know then that when two bodies are traveling in the same direction, relative speed is subtraction of the two, right? So 6 degrees minus half degree is equal to 5.5 degrees per minute, or we write it as 11 by 2 degrees, which is 5.5 degrees, right? So this is the basic concept, and all the questions would be based on this concept only, right? So let's take an example and understand it further. For example, it's 1200 hours, which means minute hand and hour hand is coinciding, right? They are at 12. We say that they are making a 0 degree angle, right? Then what is the angle when it is 12:05, right? So in the 5, how do we do it? It's simple, right? In these 5 minutes, the hour hand would move 5 into 0.5, which is equal to what? 2.5. In these 5 minutes, the minute hand would move 5 into 6 is equal to 30, right? So the angle, because they are moving in the same direction, hour hand is also moving in the direction of the minute hand. So the final would be subtraction, 30 minus 2.5, which is equal to 27.5. This could have been directly achieved by using the relative speed concept, right? So the relative speed of minute and hour hand is 5.5 and the time is what? 5 minutes, right? So this would be 27.5. So this is the utility of relative speed concept. We right away subtracted the speeds because they are traveling in the same direction and utilized it to find the angle between them at any point of time, right? So let's do another question on the similar line, which says that what is the angle between minute and hour hand at 4:56 p.m. So there are lots of ways to do it, right? What we are doing is we are going to find the simplest way, right? So at 4 p.m. the angle between minute and hour hand is what, right? There has to be some angle between minute and hour hand, right? That is what? So it would be at 3 it's 90, right? And at 4 it would be 90 plus 30, right? Which is equal to 120, right? And let the relative speed is what? 5.5. So in 56 minutes the minute hand would move how much relative to the hour hand? It would be this much, right? Which is equal to 308 degree, right? So this whole angle, let me take the whole angle, right? So finally the minute hand would be somewhere like, hour hand would be somewhere like this, minute hand would be somewhere like this, right? So it has traveled what? This complete angle, right? So this complete angle in relative terms is what? 308. We have to subtract this angle from this, right? This angle we have to subtract, right? So let's subtract this much. So it becomes 308 minus 120, which was the initial angle, and final angle between them, which is this much, this one, right? This is the final position of the clock. This is 188 degrees, right? So the final angle between the minute and the hour hand is 188 degrees, right? So this is how we do it using relative speed concept, right? There can be a simple way out also. You find that how much degrees does our minute hand move and how much degrees does hour hand move, and just subtract that. But this is equivalent to finding the relative change in the angle. So we are finding the relative change in the angle. What we are doing is, relative change is final position minus initial position, right? So if final position is in this direction, right? If we are measuring angle in this direction, this is the final angle, but initial angle was what? This one, right? So this we consider as negative angle, right? So what we say is final minus initial, which is minus 120, has to be equivalent to the relative distance traveled, and relative is 308, right? So which means final plus 120 is equal to 308. It has to be 308, or final is equal to 308 minus 120, which is equal to 188, right? So this is how we find the angle between anything. So step 1 is find the angle when it's perfect time, right? For example, if it is 3:45, find the angle between the minute and hour hand at 3 p.m., right? Or if it is 2:36, find the angle between minute and hour hand at 2 p.m., right? And then see what is the relative distance traveled by the hour hand, the minute hand vis-a-vis the hour hand, and then you can find the answer very easily. So this is the simple concept of finding the angle between the two hands at any point of time, right? There can be another question which is almost similar, right? It says, at what time between 5 and 6 will the minute hand and hour hand make a 90-degree angle, right? So what we have to find is, let's now not draw the clocks and do it right away. Between 5 and 6, right? So what we would take, our frame is 5 hours, right? 500 hours. At 500 hours, what is the angle between the hour and the minute hand? The angle would be what? It would be 150 degrees, right? So 150 degrees at 500 hours, or 0500 hours, right? Now what we want is a 90-degree angle. So can you see that there would be two 90-degree angle? So this 150 would reduce to 90 when the minute hand relatively travels 60 degrees, right? So when, in what time would it travel 60 degrees? It would be 60 divided by 11 by 2, right? Or 5.5. So this is the relative time. So this is equal to 10.9091 minutes. So after 10.9091 minutes, which means 5 hours 10.9091 minutes, it would be 90 degrees. Again it would be 90 degrees when after they coincide, right? And then it becomes 90, which means it covers 150 and it covers another 90, right? So it would be 90 when the relative distance or the relative angle traveled by the hour minute hand is 240, right? How much time does it take to travel 240? It would be 240 divided by 5.5, which is 43.63 minutes. So again there would be a 90-degree angle at 5 hours 43.63 minutes. So these are the two times when the angle between the minute and the hour hand would be 90 degrees. I hope that you got the concept really well. So what we are doing is we are finding the initial angle, right? Then to make it 90, how much relative distance or how much relative degrees should an hour hand travel, right? Relative means let's fix the hour hand, right? So minute hand, to initially it was 150 degree, finally it has to be 90 degree. So 90 degree it would become, if it travels 60 degree, or again it would become 90 when it travels 150 it would coincide and further goes 90, right? Which means 150 plus 90, 240. So these are the two times when it becomes 90 degree to the hour hand, right? Now let's go to next question, which is an interesting one, right? And this is quite an important question as far as your CAT exam is concerned. I hope that you would not get such kind of question in your CSAT or Bank PO exam, but nevertheless it's a useful way, it's an important question to do, and it will help you clear your concept, right? So it says a man left his house between 5 and 6 and returns back at 6 and 7. What he noticed is that the minute hand and hour hand has just interchanged their position. So we have to find the time spent by him outside the home. So these are the two scenarios. When he left, the minute hand was between 6 and 7, the hour hand was between 5 and 6, right? When he came back, the minute hand was between 5 and 6, the hour hand was between this 6 and 7, right? They have just interchanged. So what you can just see that this is the hour hand, this was the minute hand, right, before, and finally it became this, right? So this has traveled what? So this has traveled this much distance, which means this angle, right? This angle it has traveled, and in the same time our hand has traveled this much, right? So if you see what is the sum of the angles traveled, it is 360. Let's make use of this fact. So in the time where he was outside, the minute hand, which travels 6 degrees per minute, would travel 60, right, if he is outside for t minutes, and the hour hand would travel 0.5 into t, and this is equivalent to 360, right? I hope that you got the concept, right? In t times, what is traveled by hour hand is 0.5 t, what is traveled by a minute hand is 60, and their sum, as we can see from the diagram, is 360 degree, which means t is equal to 360 divided by how much? 6.5, which is equivalent to 55.3846. So he was outside the home for 55.3846 minutes. So this is our final answer. Seemingly a very complex question, but if you try to make the clocks and try to reduce it to the basic concepts, it would be an easy question to solve, right? So this is all for clocks. No, there is one more question. This again is a very basic question, right? So usually in exams you would be asked that there can be clocks which are lacking or which are gaining few minutes per hour or per day, right? Before going to that, let's see how much time does a minute hand takes to overtake an hour hand, right? So it's let's say it's 12 p.m. right? Now when will they again meet? So the question is, I think, slightly wrong, right? Or it is okay, we can coin it like that only, but I would coin it in more easier terms. So let's say it's 12 right now. When would they again meet, right? So again they would meet if the minute hand travels 160 degree relatively, right? And the relative speed is 5.5. so they would meet again after 65.4545 minutes, right? So if you see that they are initially they coincide at 12, they should coincide at 1.5 or nearby 1.5, right? So they would be coinciding at after 65 point some minutes, right? So 65.4545 minutes. Now there can be question in which it is said that the clock is lagging behind, right? For example, in this question it says that the minute hand overtakes the hour hand in 70 minutes of correct time, right? How much time does the clock lose per day, right? So if the clock was correct, it should coincide at after 65.4545 minutes, but it is coinciding after 70 minutes, which means it is lagging what time? Minus 65.4545, which is equivalent to 4.5455. so for every cycle of coincidence it is losing 4.5454, which means for every 65.4545 minutes it is losing how much? 4.5455, right? For every 65 minutes. For every 1 minute it would lose how much? Simple, the chain rule, it would lose 4.55 divided 4.55 we can say divided by 65.45, which is equal to what? It would be losing this much every 1 minute. So in 24 hours, which is 1 day, how much it would lose? So 24 hours means 24 into 60, which is equal to this many minutes. This multiplied by 0.0695, which is equal to 100.08. So it would be losing these many minutes per day, right? So this is the correct answer, right? So this is how we do it. We do such kind of questions. So if it is said that they meet after 60 minutes, it means the clock is gaining certain time, right? So this is the basic concept of how do we do such questions, right? I hope that you got the basic concept right, and with practice you would be able to solve all the questions as far as clocks are concerned. In our UPSC or CSAT exam, the questions from this chapter are not very tough. They are very basic, and even if you don't know the concept, you can easily put a guesswork and take a right choice from the given options, right? But it's always good to know the basic concept right, and you should be able to find the correct answer without looking the options as far as the basic concept is required, or as far as your confidence is required, right? If you can solve it, you would be able to do it with more confidence, right? I hope that you enjoyed the session. We would be coming up with the session on circular motion soon. Till then, I wish you all the best, and I hope that you are enjoying these sessions and you are improving your concepts by viewing these videos. Thanks for watching this video, and all the best for your preparations.